Z is the complex number x plus iy, where x and y are real variables. W is the complex number u plus iv, where u and v are real variables. If the complex number z is assigned to the complex number w, and it is not assigned to any other complex number, then we say that w is a function of z. For example, suppose that f of z is given by z squared minus z. Then to see what w is, we have to square z, that's x plus iy squared. So square the first term, x squared, first by second, and double gives 2ixy. Then we square iy, well that's I squared y squared, which is minus 1y squared. Then we have to subtract z, subtract x plus iy. So this is our w. Now, we want to write this in standard form, so we want to look at the real part of it. Well, that's the terms that don't involve I, so that's x squared minus y squared minus x, and the imaginary part has is 2xy minus y. We just put those I terms together. So since w is given by u plus iv, then u is the real part, which is this here, and v is the imaginary part, which is this here. So now we have the general form of w, and if we have a specific value for z, say it's 2 plus 3i, we can plug in 2 for x and 3 for y to get out the image. So we plug into here to get the real part of the image u, which is minus 7, and the imaginary part is got by plugging in here. That works out to 9. So the image of z under this function is minus 7 plus 9i. Let's take another example. Suppose w is given by 1 over z. We see that this function is not defined when z is equal to 0, but it is defined for all other complex numbers z. Now we are calling w u plus iv, so let's get real and imaginary parts of w. Z, what we input into this function, is given by x plus iy, so we have to take 1 and divide by x plus iy. So we want to write this complex number as a single complex number. As it stands, it is 2 complex numbers. We have the complex number plus 1 divided by the complex number x plus iy. To write this as a single complex number, we multiply above and below by the conjugate of the denominator. So we just change the sign of the imaginary part, so we get x minus iy. And we have to do the same on top. X minus iy times 1 is x minus iy, of course. When we multiply a complex number by its conjugate, we get the square of the modulus of the complex number. So the modulus of x plus iy is root x squared plus y squared, just from Pythagoras' theorem. That's the distance of x plus iy to the origin. If we square that, we get rid of the square root to get x squared plus y squared. Or if you just multiply these, you'll see that the cross terms will cancel, and you will be left with x squared plus I squared, minus I squared y squared. But minus I squared y squared is plus 1y squared. Now this is a single complex number. To see the real part, we just take x over the common denominator of x squared plus y squared. And then we take the coefficient of I minus y over x squared plus y squared for the imaginary part. So now we can write w like this. So if z is x plus yi, then w is given by this here. And this is unique. For a given complex number, we just have one image. Here we have a specific example of z. Z is 2 minus 1i, so x is 2, y is minus 1. We can just plug those values into this to get the image of 2 minus I. So we can get u and v, and we can find the image